rho L is given, how much it is? 4y cube microcoulombs per meters now. So the total charge q, which is given as what? The line integration of rho L into dl now. The charge is along the y direction only. So which is given as line integral of 4 into y cube into dl. I can simply say dy. So simplify it now. 4 into y power 4 by 4 limits 0 to 10, that is 10 power 4 now. 10 power 4, this is the micron. Actually this is micro means 10 power minus 6. So finally it will becomes what now here? 10 power minus 2. That means I can say 10 milli I can write. So the answer is what? 10 milli. Millicoulombs. Next, similar problem. They has given rho v given. Now they ask to find now they has given rho v. They ask to find what they ask to find here. Total charge in this region. Yes, the rho v given as what in this case? 2xyz square into nanocoulombs per meter cube now. That is volume charge density. They ask to find the total charge. How to get the charge from volume charge density? The Q, which is equal to what? Volume integration of rho v into dv. Volume integration of rho v into dv. So, and this rho v given Cartesian system, and the limit they has given cylindrical system. So what we can do here? Let us convert the rho v also into cylindrical system only. As we know, cylindrical system, the conversion relations for cylindrical system is what? X is equal to what? Rho cos phi, y equal to rho sin phi, and the z is equal to z only na. Cartesian z and cylindrical z both are same. So I can get this relation now here. So from this, what I can say, my rho v now from here, this is 2 into, yes, x into y, x, y, z. So what will get now here? Rho square into, yes, sin phi cos phi into z square nanocoulombs per meter cube we can get now. That means rho v we can say it as, that is rho square into sin 2 phi z square nanocoulombs per meter cube, isn't it? Like this. So now this rho v, which is also in a cylindrical system, and the limits also cylindrical system only now. So then we can do this integrations now here. So the total charge, what I can say, the total charge q, which is given as volume integration of rho v, how much it is? This is rho square sin 2 phi z square into dv. Now cylindrical system, the elements are rho comma phi comma z. We have rho comma phi comma z. Now we can see this element now. Change in length along rho direction, what I can say? D rho. Along phi direction is what? Rho d phi. Along z direction is what I can say? dz. So from this, what I can say here? Rho d rho and d phi and dz I can say now. So from this I can get my q. get the q now here. That is, we can split the limits now here. The row limits are what? 0 to 2, and row terms you can see this is row q into d row now. And then phi limits are what? 0 to pi by 3. Yes, phi terms are what we have? Sine 2 phi into d phi, and z limits are what? 1 to 2. So this is z square into dz. Now simplify this thing, so that is q, which is equal to what now here? Rho power 4 by 4 now, limits 0 to 2, and sine 2 phi integration is what? Minus cos 2 phi by 2, limits 0 to pi by 3, and this is what? Z cube by 3, and the limits 1 to 2, limits 1 to 2 I can say. So substitute the limits and simplify this thing. Final answer, they given the row we given nano, so should be final answer also nano will have. So this is 1 by 4 into what now here? 2 power 4 now, 4 into 4 16. Yes, this into we have 1 by 2 into 1 by 2 into what now here? Sine, so cos now here minus cos 2 pi means what will get now? 2 pi by 3 now. 2 pi by 3 means cos 120. Cos 120 is minus 1 now. So I can say this is this cos 1 minus 1 by 2 now. So what will get now here? This is, I can write it as 1 by 2 plus 1, minus will get cancelled. So this is 1 by 3 into what now? 2 cube means 8 now. And do simplify, get this answer. So this answer, and the units are what I can say? It is a nano coulombs. Right. Next problem. They has given the row V, find the total charge within the universe. The complete charge within the universe we need to find. How we can find the total charge within the universe? Universe means what I can say? That is sphere, complete sphere or not? For the complete sphere, the total charge we want to find out here. Yes, for the complete sphere, what are the limits for rho is a? Sorry, r. Limits for r is 0 to infinity, and theta is what? 0 to pi by 2, and phi is what? 0 to 2 pi. The limits in a spherical system. And this rho v now here, system is what now here? Spherical system. The elements are what we have? It is a r, theta, phi, r, theta, phi. Now, change in length along r direction is what? dr. Along theta is what? r d theta. Along phi is r sin theta d phi. Now, so my total charge, which is given as what? Total charge, which is given as volume integration of rho v into dv isn't it? Volume integral of rho v into dv is my total charge. Now we'll get this thing here. So the total charge q, which is given as volume integration of, see the rho v is this is the rho v now. Nano given, we use at the last, we use the 10 power minus nano. That is what, 4 by 3 into cos squared theta sin square phi by r square into r square plus 1 and dv. What is the dv now here? So all the three elements are required for dv now. Tell me dv now here. R square sin theta dr d theta d phi. R square sin theta dr d theta d phi. So that is q, which is given as 4 by 3 constant, and r square को मारा. Simplify the terms now, get that, separate the terms now. R limits are 0 to infinity, and see the r terms, what we have, the r terms are 1 by 1 plus r square into dr, and the theta limits are 0 to pi, and the theta terms what we have, cos squared theta into sin theta d theta. Phi limits are what, 0 to 2 pi, and this is sin square phi into d phi. Isn't it? Now do simplify this thing here. So this is 4 by 3 into, this integration is how much it is, tan inverse of r limits 0 to infinity. Yes. Now you can see here this term here, the integration of this term, integral of f of x power n into f dash x, if we have this integration, is what, f of x power n plus 1 by n plus 1 we have. So here we should apply the same property here. F of x is a cos theta, f dash x is minus sin theta, but no minus, so multiply with minus. So what I will get now here, minus cos cube theta by 3, and the limits 0 to pi, and this is sin square phi. What we can say here, this sin square phi, hope you remember this analysis. If the theta limits are 0 to if we have, may not be theta, anything, if it is 0 to 2a, if we have like this form, f of x into dx, if we have like this we should write, if f of 2a minus x is it may be equal to f of x, or if f of 2a minus x which is equal to minus f of x, in that case we have a relations. If it is not f of x, if it is not minus f of x, there is no other relations. So if it is same, then what we can say now here, in this case this will write it as a 2 times of 0 to a f of x into dx, I can say, and this is what, in this case it I can say it is 0. In that case I can call this as a 0, isn't it? Like this we need to see. In this case now can I apply this property now here? You see here this thing here, theta limits are what now, theta now phi limits are what now, it is 0 to 2 pi. We have what we have, it is a sin square phi into d phi we have now. Now you can check this thing whether this property satisfy or not. Here sine 2 pi minus theta sine square now, so will become same function will becomes, so I can write this as 2 times of 0 to pi. I can say this as sine square phi into d phi, and again if we apply one more time, so this will be 2 times, again 2 times of what now? Now the phi is from where to where? 0 to pi by 2, and this is sine square phi into d phi now, isn't it? Can apply again. When you add again, so this is sine pi by 2 minus theta, that is not f of x, not minus f of x now. We write again sine pi by 2 minus theta, that is cos theta, that is not f of x, not minus f of x now. So we cannot apply this property again, so we need to stop here only. So what I can say, this is now here finally this is 4 times of what? The phi limits are what? 0 to pi by 2, and this is sine square phi into d phi. Now we'll do simplify this thing here. So this is 4 by 3 into this is, this will become tan inverse of infinity means pi by 2, and we can replace here. This is how much we'll get this value. So this is 2 by 3 now, plus 2 by 3 minus 2 by 3 plus 2 by 3 into 4 times, and this is here we'll do one more property here. One more theorem. So if we have, if the limits are theta from 0 to pi by 2, if we have, and sine power n theta d theta expansion, tell me the sine power n theta d theta expansion of this term. This is what I can say here, n minus 1 by n, n minus 3 by n minus 2. Like this we should keep on decrement to continuously. Now if we have the function is like this, theta is from 0 to pi by 2, and tell me now here sine power 9 theta d theta, this expansion, what I can say. So it is what now here, 8 by 9, continuously decrement to 8 by 9. Next what, 6 by 7. Next what now, 4 by 5. Next 2 by 3 now, like this. And here last one is a 1 only now. If theta limits are 0 to pi by 2, and tell me sine power 10 theta d theta, this expansion of here 9 by 10, isn't it? Next 9 by 10. Next, yes, we should keep on decrement 2 now. Yes, 7 by 8, isn't it? 5 by 6. Next 3 by 4. Next, can you do one more? 1 by 2. If the last one is a 1 by 2, what we need to do? Multiply with a pi by 2. The last one is a 1 by 2. We need to multiply with a pi by 2. Hope you remember this analysis. And this formula which is applicable only when theta limits are 0 to pi by 2 only. That's why only we have converted this function into in this form, 0 to pi by 2 form, isn't it? So now you tell me what is the answer in this case now here. Yes, this value. So this is 4 into, so this is 1 by 2 now, 1 by 2 sine power n formula, 1 by 2 into what I can say, pi by 2 directly. Yes, why pi by 2 again? If the last one is a 1 by 2, we should multiply the pi by 2, isn't it? So finally, check this answer. What will get now here? 4 pi squared by 9. The units are what? Nanocoulombs. Like this, we need to solve it.